Okay, let's continue with the conditional branch. Okay, what is conditional branch? The conditional branch means that when you want to do branching, you will look at the CCR, which is the flags. So remember that we learned about the flags before. So those flags basically is going to give you informations, and then the system know where it will go accordingly from the latest result from the flag. Okay, conditional branch is branch performed in program according to the flags of CCR. Okay, the flags are modified by previous instructions in the program. So you remember that when we have the example before, when you do a subtraction between A and B, if the result is equivalent to 0, then your Z flag will be equivalent to 1. So if your A minus B is not equivalent to 0, then your Z will be always 0. Z is equivalent to 0. So based on these two conditions, then the system will know whether you want to branch or not. Okay, the purpose of the conditional branch is to transfer control to a new location in the program depending on a certain condition. Okay, depending on a certain condition. So the syntax will be like this: BCC. This is the syntax. We call it BCC, right? The BCC. This is the condition code, So this is the label where you want to put, where you want to jump. Anyway, when you jump over there, okay. Let's look at the example of the syntax. This is all BCC, okay. So you have this BCC HI, you have this one LS, you have this one CC, you have CS, and all this one got meaning to check. For example, BHI is checking C plus Z is equal to 0, then it will decide whether you want to branch or not. So we are going to concentrate on two examples here, which is they call it BNE and BEQ. So in your slide, you just need to remove this one. There's a wrong things over here. The meaning of BNE is just branch not equal. So 20, you remove that one. This one also 20, you also to remove that one. So the meaning of BNE and BAQ is a branch if not equal, and it will check the Z flag. Okay, if your Z flag is equivalent to 0, then the branch will happen. Okay, means that the branch will happen. I'll show you what happened later. So the next example is BEQ. They call it branch if equal. So BEQ is looking also at the Z flag. If your Z flag is equivalent to 1, then it will branch. For this case, your Z is equivalent to 0, then it will be branch. So how it works? So you have to look at the software, how the program works. So I'm going to have an example here. Okay, the example is I have a command here. Normally, for example, let's try the normal one that we have before. So I just remove this one first. Okay, so last time we have all this command move.long $sign hash11 to d1 move.long hash $sign 55 to d2. Okay, when you run this one, right, when you execute it, when you go it one by one, the program is basically going down from here to here. So if you have a lots of lines here, you just write one lines, the program will be starting from here and going to execute one by one the line. This is the normal program. So when you have a program, like for example, you want to have a loop, they call it loop, right? Loop is actually a lingkaran loop, which is going to continuously run the program. So we are going to write down a loop like this. For example, we have this command. So you can try here. This is the label init, then the label loop, and this is the another command after that. Move dot w hash sign dd to d4. Okay. So you have this command. This is just a label of the name. And also this is also a name for the loop. It's just a name. So you can put any names as a label. So I just want to put as things that I can remember that. So you have move.byte. The first command is move.byte 3 to D3. And then it will go down. And then in this line, it will sub immediate 1 from D3. So now D3, the value of D3 is having this value 3. So you have D3 is equivalent to 3. 3 minus 1 is equivalent to 2. Okay. Let's try to look at the how it works first. Okay. Now you have this one, D3 is equivalent to D3. D3 is equivalent to 3. You minus out 1, right? You minus out 1. So 3 minus 1 is equivalent to 2 when you execute this line. And then when you do this, right, you know that when you do arithmetic operation minus, the CCR flag will change accordingly to the results. So for example here, 3 minus 1 is equivalent to 2. So if you can watch your Z flag still equivalent to 0 because this value is not 0. This value is not 0. So then after this command is completed, you will go to this one. This command will check BNE, check the Z flag. Okay, I repeat, BNE will check the Z flag. If the Z is equivalent to 0, it will go and branch the loop here. Okay, if your Z flag is equivalent to 0, then your code will go to this branching. So if there's no branching, it will still go down. But now, because of the Z is still equivalent to 0, it must do the branch here to loop. Loop is this label. Okay, so loop is this label. And then you can see that when you execute this command, you will check Z is still equivalent to 0. Then you will go to loop here, do this one again. So right now, your D3 is still equivalent to 2. 2 minus 1 is equivalent to 1. Your Z is still equivalent to 0. So you go down again here, check again the Z flag. The Z flag still 0, so you still have to branch to the loop. Okay, go again up here. So example here, you have the final one, 1 minus 1, then it will going to be 0. Your Z now is going to be 1. Okay, your Z is going to be 1. And then now, when this command looked at the Z flag is equivalent to 1, it will not going to loop to this one again because the system knows that CCR flag is already Z is equivalent to 1. So it will go up from this loop and going down. So that's the theory of BNE, checking the condition of Z flag. So let's try to look at the command here. Alright. Now, I run it one by one. So, one by one, I run it. Is go to the loop label. So, you see that D3 is still equivalent to 3. This is the initial value. So, you minus up 3 minus 1, 2. Your BNE looking at Z flag is still equivalent to 0. So, this command say you must branch to this loop if I found that Z is still equivalent to 0. So when I run this one again, it will go back to the loop. You can see that it will go back to the loop. Okay, so now your loop is doing the same thing again, sub immediate 1 from D3. Your D3 now is still 2. Okay, 2 minus 1 is equivalent to 1. Your Z flag still at 0 value. So checking at Z flag still 0, it must loop again. You must branch to this label, which is this loop. Go up again. And then you have this 1 minus 1. 1 minus 1. And you can see that your Z flag now changed to 1 because of the Z is already looped that the result is already 0. So this command say if you see that Z is already at 0, you have to go out from the loop. You have to go out from the branch, it will go down. So look here, it will go down. And then move continuously. Alright, so if I put branch always at the end of the program, branch to init. Okay, so you can see that you are already going to loop. So this is always a loop. Your program will not stop because it's always waiting for the what do you call it? There's no stop. I mean that there's no you can insert any input, but now there's no input looking at the there's no input output here, so you can see that it's always loop. It will not die. I mean this program is consistently have the continuity, because if I do not have this branch, then it will go down and end. Okay, so that is for BNE and branch. Branch is the first one that we learned just now. So this is, I already combined it together. You can see that this is how it works. So how about BEQ? BEQ is checking what? BEQ here is checking if your Z is equivalent to 1, then you branch. Okay. Now for example here, let's try to write a code. BEQ. So this one directly 1 to 1, right? I mean 1 to 1, 1 minus 1. So BEQ, let's put this one to next. Go up there. So whether it is going to here or not, let's try. So right now this is the label, this is the command that we have. And then this is another label, this is command only 1 to D3. Sub immediate 1 to D3. BEQ loop. BEQ loop, this one I change it BEQ next. Okay, next means it should be going up here. So BEQ is checking that, this one for the BNE just now. So BEQ, so just now is the BNE checking the Z flag. If Z flag is equivalent to 0, then you branch. If Z is equivalent to 1, going out from branch. Okay, now BEQ. BEQ is sort of opposite of it. So if you see that Z is equivalent to 1, you branch. So if Z is equivalent to 0, do not branch. Okay, let's try to look at this one. Example here. You run it one by one here. Now, this comma is moved up by 1 to D3. So your D3 is going to have 1 here, right? And then this comma is sub immediate 1 to D3. So 1 minus 1. 1 minus 1 here. 1 minus 1 is equivalent to 0. So your Z flag going to be 1. So BEQ say, if I see Z is equivalent to 1, I will branch. So this one going to be a branch where? Branch to next. So it's expected to go here. Okay, let's try. BEQ, now your Z flag is already 1. So now if it moves to next, correct. We move to next. Right? See that one? So let's change another one. So let's say, for example, here, let's try to put not equivalent to 0. Let's try to put here 2. Okay, let's try and run here. So you run this one. So 2 to D3. D3 now is going to be 2. 2 minus 1. 2 minus 1. 2 minus 1, Z is equivalent to 0. In BEQ say, if Z is equivalent to 0, there will be no branch. So you will go here, going here. Instead of going up, you will go here. So let's look at the results. Yes, it's going down. So that's the reason why the how this is actually how you want to control your program. That's why they call it conditional branch, because this branching is looking at the CCR flags to make a branch or not to make a branch. So that's why they call it conditional branch. The branch always, this is unconditional branch because it's always going to do the same thing no matter what happened to the flags over here. It was always going to branch always to init. Okay, this is init, you will go here, you will go here. Okay, let's try to look. So you will go here. So you have to imagine when you write a program, you can write a program from the top to the bottom, and then you are going to look at how your algorithm should works. That's why the importance of understand the flowcharts of your program, and then you can try to write down the code piece by piece. So you have to imagine that the code is very fast. So that's why you have to do one by one to look at the result. What happened on every lines that you write down. Okay, so that is the introductions for the conditional programming. This is conditional branch. So you can see that here, this is the example for conditional branch, and the rest is the one that about the if-else statement. It will be covered later. Okay, so if you go back to understand the C programming, this is where you are learning about the if-else statement, the do-while statement. This is all the loops. It's how you want to write it by using assembly. So it's different from C++. Okay, so hopefully that you guys can understand, and this one going to be applied in your lab. So good luck on your lab. Try your best and to complete the task. Thank you very much.